Okay, so now we're going to do section 8.3, which is perimeter and area. So first of all, what is the perimeter of any shape? The perimeter is the measurement of the outside of that shape. The measurement of the outside line that encompasses the two-dimensional shape. Figure or shape. So for example, we're going to find the perimeter of the following figures. So we have a rectangle here where this length is 8 feet. The width is 4 feet. To find the perimeter of these, we need to find the length of all of these lines together. So we know, since it is a rectangle, that this is also 8 feet and this side is also 4 feet. So what we need to do is add all of these four sides together. 8 plus 8 plus 4 plus 4. So this is equal to 24 feet. Since it is a line that we're measuring, the line that encompasses this rectangle, then the unit is feet. Then we have, here we have a parallelogram. And also we're going to be measuring the outside line of this parallelogram. Well, this is 3 meters. This will be 3 meters also. And this is 27 centimeters, which means this will be 27 centimeters also. So we don't care about this side, this measurement, because this is the height. This is not an outside line of the parallelogram. Now, in order to find the perimeter of this one, we need for all of them to be in centimeters. So if you have 3 meters and you have 27 centimeters, you can't add them together. So I would turn 3 meters into centimeters. Since 1 meter is equal to 100 centimeters, then 3 meters is equal to 3 times 100, which means 300 centimeters. So in order to find this perimeter, we're going to add all four sides together in centimeters. So we have 300 plus 300 plus 27 plus 27. This is equal to 654 centimeters. So one thing to be careful with in this section is that you pay attention to the measurement, that all the units are the same. So that's what we did here. We turned the 3 meters into 300 centimeters. Then we have a trapezoid, which we talked about in section 8.2. It is a quadrilateral. So it also has 4 outside lines. So we're going to add those lines together. So we're going to add this line plus this line plus this line plus this line. We don't care about this one because this is not a measurement of the outside line that encompasses the trapezoid. So the perimeter in this case is going to be 25 inches plus 5 inches plus 25 inches plus 19 inches. So that would be 64 inches. Let me make sure that this is correct. 25 plus 5 is 30, plus 25 is 55, plus 19 is actually 74 inches. So make sure also that you add it correctly. So we have that the perimeter of this trapezoid is 74 74 inches. And then last in these examples, I want to talk of real life situations in which we would calculate the perimeter. Where do we need to find the perimeter to do something in a real life situation? For example, when we want to put fence around a yard, we have to measure the line that encompasses the yard so we know how much fence we need to buy. So we know how much fence to buy. In feet or in yards, depending on how they sell this fence. Now we're going to talk about the area of a shape. So the perimeter we talked about being the outside line of the shape. The area is the measurement of the inside. Measurement of the inside. Of the inside of the figure. This is done in square units because we're doing a two-dimensional figure, and we're gonna find out how many square units are inside of that shape. So let's talk about the formulas first. These formulas are gonna be given to you for your final exam, so you don't have to worry about memorizing them, but you must know how to use them. Okay, the formula for the square, for the area of the square, is side, since the sides are the same, is side times side, which is side square. The area for the rectangle is length times width. The area for the parallelogram is base times height. And the base and the height are perpendicular to each other. Base and height are perpendicular to each other. Then we have the area of a triangle. This would be 1/2 times the base times the height. And the base and the height are also perpendicular to each other. Then we have the area for the trapezoid. The area is going to be 1/2 times the height of the trapezoid times the big base plus the little base. The big base and the little base, these two right here, these are the two parallel sides. The two parallel sides. And also the height and the bases are perpendicular to each other, like in the case of the parallelogram and the triangle. So let's do a few examples on how to find the area of different shapes. We have the area of this square. Since one side is 6 feet, we know that all sides are 6 feet. So the area will be 6 times 6, which is 36 feet squared. We must remember that it is done in square units, so it's 36 feet squared. Then we have this parallelogram. So we have this base and we have this measurement here that would be useful if we were doing the perimeter, but we're doing the area. What we need is the height, which is perpendicular to the base. So this is the base and this is the height. So to find the area of this parallelogram, we will do 13 inches times 6 inches. We make sure to read the units so we make sure that they're the same units. And 13 times 6 is 78 inches squared. That's the area of this parallelogram. Okay, then let's go ahead and find the area of this trapezoid, which is, we have the formula right here. So first of all, we notice that all of our units are in inches, so we have the correct units for all of them. And then we're going to identify what's what. So this is the two sides that are parallel to each other. So this is the big base and the little base, so big B and little b. And this is the line that is perpendicular to the bases. So that's the height. So we're going to go ahead and write the formula. We have 1/2 times the height, which is 12, times the little base plus the big base, or big base plus the little base, which is 16 plus 6. So that will be 1/2 times 12 is 6. And then 16 plus 6 is 22. Now we can multiply these two things together. And that's 132. Since the measurement is inches, that will be inches squared. So in what situations, what real life situations do we need the area of a region? When do we have to calculate the area so we can apply to our real life situations? For example, if we are going to lay tile, we need to calculate the area of the floor where we are going to lay the tile, so we know how much material to buy. So if we're going to do flooring, we need to know the area. So we know how much to buy, how much material to buy, how much tile, how much grout, how much glue. And this is a concept that is very useful when we are doing construction. So it's not only for flooring, but also for painting, for sod, and for different things that that we use materials in construction. Okay, now we're gonna do the circle. So we did the perimeter and the area for different geometrical figures, different kinds of polygons, but now we're gonna talk about the circle, which is not a polygon. The definition of a circle is a circle is a set of points equidistant to a fixed point called the center. So if you look at a circle, this is the center, and all of these points are equidistant, which means are at the same distance. They're all at the same distance from the center. So that's what the definition of circle means. Equidistant means at the same distance. What is the circumference of the circle? The circumference is the measurement of this line, the measurement of the line that encompasses the circle. Measurement of the line that encompasses the circle. So that would be like talking about perimeter. Then the formula for circumference, there are two ways that we can write the formula for circumference. We can say is 2 times the radius times pi. But also, since 2 times the radius is that distance from the center to the circle, but also across the circle we have the diameter. So 2 times the radius is the diameter. So another way to express the circumference is diameter times the radius. So you can write it as 2 times the radius times pi, or the diameter, not times the radius, but the diameter times pi. And then the formula for the area is the inside of the circle. The measurement of the inside of everything that is inside of the circle is a two-dimensional measurement, and this will be pi times r squared. Now let's do a few examples on how to find the circumference and the area of these two circles. So the circumference of this circle would be circumference equals 2 times the radius times pi. That would be 2 times 7 times pi, which is 14 pi centimeters. This is an exact form of expressing the circumference. Now, if you need to do a decimal approximation of the circumference, I will allow you to use a calculator for this test, and you will do 14 times pi. And that will be, I'm going to round it to 2 decimal places, 43 times 0.98 centimeters. So this is the only test. Remember, on the final, you will not be allowed to use a calculator, but I am okay with you using a calculator on this homework. And the area of this circle would be, r squared times pi. So that would be 7 squared times pi, which is 49 pi. So this is the area expressed in exact form. We just leave pi as pi. If we want an approximation, we would use our calculator. 7 squared times pi. There was a problem. 7 squared times pi, and this is 153.94. 153.94 square centimeters. So this is the exact value for the area, and this is an approximation rounded to 2 decimal places. Now, when we have this circle and they're giving us the diameter of this circle, what we need is to use the formula that uses the diameter, which is the circumference equals d times pi. Since the circumference is 16, we can write it as 16 times pi. And it is yards. So you can write 16 times pi yards. And if you want an approximation, then you would multiply 16 times pi, and that we're going to round to 2 decimal places. That would be 50.27. 50.27 yards. Now to find the area, it is r squared times pi. Well, since the diameter is 16 yards, then that means that the radius is 16 divided by 2, which is 8 yards. So we need to calculate the radius for finding the area. So we're going to do 8 squared times pi, which is 64 pi yards squared. And the area, an approximation, when you put this in the calculator and you multiply 64 times pi, that gives you 201.06 rounded to 2 decimal places. So this is the exact area, and this is an approximation of the area rounded to 2 decimal places. Now we're going to do an example in which we are going to mix some of these formulas, and it's a little more interesting example. It says to find the area of the shaded region. So we want the area of the yellow part. So part of this is going to be very simple. Like what we're going to do, we're going to do it in little pieces. We know that from here to here, this is kind of simple because we know that all the way is 30, but we know that this little piece from here to here is 10. So that makes this piece 20. So the base of this rectangle is 20 inches. And we know that the height, since this is 10, this has to be 10 also because we see the circle inscribed in it. So the area of this rectangle is going to be 20 times 10, which is 200. So we have that so far. We have 200 plus, then we have this whole square. That would be simple because again, we have a 10 by 10 square, which is 10 times 10, and that is 100. So we have 200 plus 100 plus these little pieces. So this is the difficult part of the problem, where we have to find the area of the square and subtract the area of the circle from it, which is the white part. So area of square minus area of circle. That will be 100 minus, well, the area of this circle, the radius is 5 because the diameter is 10, which is from here to here is 10. So we have 25 pi. So this little area is 100 minus 25 pi. 100 minus 25 times pi is going to be equal to 21.46. So we're going to add this whole area plus this whole area plus this teeny tiny little area which we calculated here, plus 21.46. So we have 321.46 inches squared. We're going to look at the Pythagorean theorem now. So to apply the Pythagorean theorem, we have to have a right triangle. That's the one that one of the angles is going to be a right angle, which is a 90-degree angle. So in a right triangle, what is the name of the side opposite to the right angle? So this is the right angle and this is the opposite side. That is the hypotenuse. In a right triangle, what is the name of the longest side of the right angle? Of the triangle. The longest side of the triangle happens to be the same as the side that is opposite to the right angle. This is, again, the hypotenuse. That is the longest side of your right triangle. So the Pythagorean theorem formula, so we're going to call the sides A and B, and the longest side, or the hypotenuse, we're going to call it C. So I'll rewrite my triangle here. There is my right angle, A, B, and C. So the hypotenuse, which is C, C squared is equal to A squared plus B squared. So the sum of the squares of the two smaller sides is equal to the square of the longest side. So you always have to look at your triangle And look and see the two sides forming the right angle. Those are the short sides or the legs. And the one that is not forming the right angle, that is opposite to the right angle, that's the one that is going to be always alone on the other side, which is the hypotenuse. So here we have that c squared equals 8 squared plus 15 squared. I noticed that this is yards and this is yards, so everybody's in the same kind of unit, so that's good. So c squared equals 64 plus 225, because 8 squared is 64, 15 times 15 is 225. So c squared equals 64 plus 225. That would be 289. 4 plus 5 is 9, 6 plus 2 is 8, and then, so the hypotenuse, which is c, is the square root of 289. So in order to get rid of the square, we do the square root of both sides, so we end up with the square root of 289. 289 happens to be a perfect square, and I know that because I know my perfect squares, but you can also look it up on your calculator and see that the square root of 289 is 17. And so it's the longest side, which is C, is going to be 17 yards. If, or on the final, you know you will not have a calculator, you can do it by trial and error and figure out which number, when you square it, will give you 289. So now we're gonna look at example number 10. So we have the two legs, which are the two sides of the triangle that form the right angle. So we know that one is 5 kilometers, the other one we don't know it. So we know that this is 5 squared, which is a squared, plus b squared, which we don't know what it is equal to c squared, which is 13 squared. So remember, the longest side, which is the hypotenuse, always goes on the other side of the two legs. The sum of the square of the two legs is equal to the hypotenuse square. So you have 25 plus b squared equals 169. And then we want to subtract 25 from both sides. And this gives us that b squared equals 144. Now, in order to eliminate the square, we need to do the square root of 144. And this is one that my students usually know really well. The square root of 144 is 12. Since all the sides of the triangle are kilometers, this would be also kilometers. So the size of the other side of the triangle is 12 kilometers. So now, this is what the Pythagorean theorem is. Do it in pairs. John and Elizabeth's home is illustrated here. They wish to hire a lawn service to cut their lawn. M&M Lawn Service charges $0.03 per square yard of lawn. How much will it cost them to have their lawn cut? So here is a picture of the lawn. And you can see where there is no lawn. There is a circular pool. There is the house, the driveway, the patio, and a little shed. So all of those little pieces don't have any lawn. So the person, John and Elizabeth, will only have to pay for the green part. So I want you to do this exercise and bring it to class and show me what is the area and how much it is going to cost them to have their lawn cut.